And then we'll turn the stream back on for some of the talk and discussion and other things I have to say too. So it's a little bit awkward and cumbersome. I'm not that comfortable with doing it. We'll see how it works. It might be clunky for some of you at home, but if you can look at those videos, you'll see some fantastic ideas of what's going on. The photography is so stunning and clear, and the discussions, the way that you get some of these scientists talking about what they're doing, and you see the passion of what they're doing, their life work. I think it's very much worthwhile to see it that way. So if you can, at the appropriate time and you're at home, and you navigate onto your YouTube station, and we'll have directions as to how to get to those parts. All right. So I wanted to talk about, got some extra papers up here. I came up here and there were 8 boxes of Kleenex up here. So I don't know what the last meeting was up here, but I hope we don't get to the need of that. But if it gets that intense, the napkins and the Kleenex is right over there. All right. So basically, wanted to start talking about the 4 planets. You know, I don't have the clicker, sorry, up here to move. And if we do have some talk or discussion, Joanne will come around with a microphone so that it can get captured on, like we usually do, captured on the streaming service as well, too. So you can see here the planets of our solar system. It even shows the dwarf planet, imposter Pluto, way at the far end of the screen there. I could have clipped it off, thank you. I could have clipped it off, but I left it on because it's an emotional thing for some people. We talked last time about Mercury, and this shows relative sizes, but obviously not relative distances. But this shows Mercury, Venus, Earth, similar sized, Mars, much smaller. And we'll talk about some of that today too. Obviously, the big behemoth is Jupiter and Saturn, Uranus and Neptune. Okay? And that's probably about as far as my teachers got with me in about 4th grade, right? We could name the planets, and we learned the mnemonic. We heard, "My very elegant mother just sat upon another pin." And that was the one we had. There may be others that you have as well, too, but all right. So just some immediate introductory facts about Jupiter. It's 22 Earth diameters across. I didn't think last time I gave good comparative sizes of some of the planets, but it would take 22 Earths stacked across it to take up that diameter, which doesn't sound that much more enormous, but it also means that 1,321 Earths could fit inside it, right? So it's that volume across and up and out, you know, it's a cubing of the radius kind of thing of volume. So it's 5 astronomical units distance from the sun. The astronomical unit is a development and understanding of a relative place in space. The Earth averages distance from the Earth at 93 million miles is called 1 astronomical unit. So if you see 5 astronomical units, you can say 5 times as far away from the sun as the Earth is. So it gives you some understanding. And as we go through, that should start expanding more too. It's closer in than the other planets that are the other gas and ice giants there. They keep on finding, I think they're saying there's somewhere around 20 satellites of Jupiter. They are still trying to, are sized close to Earth or Earth's moon at times, are sized close to Earth or Earth's moon at times. And so those are moon satellites that travel around Jupiter. But scientists like to see how many they can count, and they're up to 65 moons. So I wore my closest to Jupiter shirt today, too, I wanted to show you. So the stripes are actually, anyone know what those stripes really are? Interesting to see those stripes on there. The stripes are clouds and weather. and they actually are traveling in opposite directions. You can see in some places the kind of turbulence that's caused by these flying around here. And the red spot, the Jupiter's Great Red Spot, has been there for 300 years that we know of, right? And it's a storm that's lasted, a Jovian storm that's lasted for 300 years on the planet, right? Affecting the atmosphere. The thing that you start realizing when you're talking about these gas giants, we talked a lot 2 weeks ago about the rocky planets, and they have a core and a crust and a mantle and a crust and so on, very metallic. But these things have a whole different kind of structure to them, and there's no real surface out at this level out here. That's just the extremity of where the atmosphere, the hydrogen and helium atmosphere that makes it up, is still pulled by gravity into a spherical kind of shape. So you'll see that if you would drop a probe onto this planet and all of the gas giants and ice giants, they wouldn't really land on a surface there. That's not a surface. That's just the top of the clouds that you can see. They're kept in a atmospheric kind of swirling kind of pattern. So some travel some travel clockwise, some travel counterclockwise. You can kind of see the ways they flow because of the remnants of what's happening here. These are getting bundled up and botched up by this big storm, and then they stream out past it on either side. So it's an amazing thing. These other ones are going this way. The red one here is going that way. So fascinating kind of structure of what's happening. We have similar to that on our Earth with the different horse latitudes and so on, the weather on the Earth. But this is an amazing prospect of the structure of the planet. All right. So if you're at home, if you can get onto youtube.com, and this is a video, Jupiter, largest planet in our solar system. It's on, if you put that in the search engine, Jupiter, largest planet, even it'll search and it'll find that. And we're going to watch for about 20 minutes. At about 20 minutes and 30 seconds, we're going to end it. And this is a longer one of the two that we'll watch today, but it's pretty amazing to see the people that are involved in this. And it's a BBC Earth Science video. Okay, so I think we're shutting the stream down, and we're going to set it up in back there. And when we're ready, we'll go on to that. more on that video, but I thought that was fine to get a taste of what's going on there, give you an understanding, a bit of Jupiter, and also some of its moons. Like he said, there's 4 main moons, and they all work in resonance with each other. Io is one, and that's the closest, and you can see how battle scarred and volcanically adjusted that is. And his point is that that's kind of gives us maybe another picture of what early life on our Earth was like, or early times on our Earth before life. Europa is another, and they have a plan to go there called the Europa Clipper, a probe, sending a probe there. Interesting things, that Io probe that he was talking about to check the volcanic and do the flybys and so on, that actually was put in for funding and it didn't get funded. So his passion is not going to be looked at, but they're feeling, they're prioritizing what they want to do. There's been a few probes that are going to Venus in the next short while that they're preparing, and those got funded, and some others that we'll talk about got funded as well too. But imagine the disappointment the day he heard his passionate ideas weren't going to be funded. Any thoughts or ideas or questions about Jupiter that you want to bring up? Here's one, Joanne.
Here I come.
One quick comment and a question. Jupiter is actually 88,000 miles in diameter, so it's 11 times Earth.
11 times Earth's diameter?
Um,
It's working. We're hearing it. Yeah.
Testing. So it is kind of interesting, some of the pictures of Jupiter. It's hard to tell if that's like what we would see with the naked eye, or if it's like, adjusted when they take the imaging. Do you know if most of those were like kind of what the human eye would see?
I think, it would have to be enhanced by lensing, right? By looking at it through some type of lensing to expand the view. But no, I think that those colors are there, and yeah, the red spot and the other colors are there. This may have been enhanced. They may have had some filters to make it even more apparent, but you can see the bands of it pretty well. Mm-hmm. Yeah, amazing planet.
How was Jupiter named?
Pardon me?
How was Jupiter named? How was Jupiter named?
How did it get its name? Made. Okay. It was originally thought of, and there are some very interesting things you can see online too. But basically, all these ice and gas giants were small, rocky cores, planetesimals, they called them, small gatherings that kept accreting, kept coming together, bonding together by small gravitational forces. The whole solar system started as just a gas cloud out in space. And then as things kept moving together, getting pulled together, most was pulled together by the central force. It was spinning around, so there was energy from that. The central force pulled a lot of the gas and hydrogen and helium towards it, and so became the sun. The other ones out there were small rocks. The ones close to the sun had no helium and hydrogen. That was pulled towards the sun, and so they just stayed as terrestrial objects. Jupiter and the other giants started out as these same rocky cores, they believe, and a lot of this is still being deciphered. We haven't even had probes land on any of these places yet, so there's a lot to find out, and there's a lot for young people to get involved with the science of the solar system.
I think another question was, why is it named Jupiter?
You said, why was it made?
Name, Name.
Oh, I'm sorry. Well, let me finish up how they think it was made, and then I'll say named. I'll talk about that too. So as it as it was, the planets, the small little objects that were farther out in space started gathering, and ones that were slightly bigger gathered more and started clearing out that area of their orbit around the sun. And they gathered and gathered and gathered. But they also gathered, as they got to a certain size, they gathered the helium that wasn't pulled into the sun, the helium and hydrogen. They were far out in space, weren't pulled so quickly to the sun. They think that it only was maybe 3 to 4 million years that they had time to gather to the size that they did. And so then there was quite a bit of fast work to get to Jupiter the size it was in maybe 3 or 4 million years. So that's how they formed. Named, it's interesting because there's only really been two planets that we know who discovered those planets. Um, Cavemen knew about all these Mercury and Venus and Mars. In fact, when they talked about the seven planets at that time were the wanderers in the sky, and they knew of five of them, five of the what we call planets, and then they called the sun and the earth and the moon also were involved in that too. So they knew about Mercury and Venus and Mars. Those were known and in the sky, and ancients talked about those, right? All those were known. The first discovery of a planet was actually in about the time of our American Revolution, in I think 1780s or so, when a man who had a telescope in his backyard saw something in the sky. People like to look for comets, and he thought he found a comet, and he just wrote it down, found another comet, but it's a funny one. It doesn't get fuzzy and so on. Like most comets do, it has no tail. And he kept observing it for a while, and finally he overcame his original thoughts and said, this must be a planet, which was very striking because everybody thought that the ancients knew exactly how many planets there were. There's nobody that knows. So it got its name, the ancients named the planets, and they named them after their gods. So Jupiter is the god of the Roman head god, right? And the biggest planet, the largest, one of the brighter ones, to them was named Jupiter. And they had all the passions, and astrology was big at the time. Astrology was almost their science. So they had the powers that came because of people that were born when Jupiter was high in the sky. And Galileo, in fact, who first saw the moons of Jupiter, he wrote to his benefactor, the person that gave him all the money to let him do all the things he liked to do, and did an astrological chart for this. And this was, you've probably heard of, I think it was Cosimo Medici, and who became a pope. And that helped Galileo's work for a while until he started doing some things that the popes didn't like. and so, anyways, all these planets were named after Mercury was a god, right? Venus was a goddess. You know, Mars was a god. Jupiter and Saturn were all gods of ancient peoples, mainly ancient Roman gods. And so then they started naming a lot of the moons of those planets after Greek associates of those gods. So that's how it got named. Okay? So Saturn. I've got this at 9.5 Earth diameters across. 764 Earths would fit inside it, formed very similarly to how Jupiter did, like I described earlier. It's 10 astronomical units from the sun. So we think it's just, there's as much distance between the sun and Jupiter as there is between Jupiter and Saturn, right? It's far out, much farther out there. And again, many moons surrounding it. And that has to do with some of the thoughts about how the so visible rings got formed. I've never seen it or seen pictures taken, but actually I think if it was Galileo, somebody saw the first rings, the rings of Saturn, identified them for the first time, but he only saw them on the sides of the planet. And he actually described them as ears. He thought they were like ears of the planet, and the ears were always there for some reason. So But beautiful pictures taken with some of the Voyager probe that left in the 70s and so on of all the rings of Saturn. And there's some fascinating things of that as well, too. So this is a much shorter one, about 6 minutes and 40 seconds. Saturn, and talking about some of the passion in these scientists is just so evident that it really, really is exceptional. So if we can get to that one, if you're at home and you can get to the YouTube station, and this is Saturn, the solar system's greatest jewel. a tree would show wonderful life on the planet. So there was a little bit, I had to listen to that a couple times to really understand what her point was. But yeah, it was just so neat to see the passion in their hearts. The one woman talking about the structures, and it, if you looked at those pictures, you could see that there was like a gap in the rings, right? And what makes the gap in the rings? A small orbiting rock, right? That's going at a different speed. And then if you looked at it carefully, you saw that some of the jagged parts, they're kind of like what's thrown up almost on a wet slushy day on driving a car or something, right? It'll throw up piles of old snow and things like that behind you. But if you looked at it, if the as you saw that one picture, the orbiting rock was going, and on the left side of it, on the inner side of it, the the detritus, the thrown up stuff was behind it, and on the other side, it was in front of it. Did you notice that? And that's because the rings are rotating at different speeds, right? If the rock is there relative to the rock, one is going back this way behind it, right? So it's scouring through this thing and throwing up things that fall behind it. But out here, this ring is going faster than the rock is, orbiting faster. And as it's going, then it's going faster than the rock. So the thrown up material is in front of the rock, right? Relative to the way the rock's going. So that's pretty interesting to see that this thing scours like that way, and then they settle down for a while after that. It's thrown up and out of equilibrium and then back down, but in different directions. All right. Yeah, there's just so much you can keep on looking and talking about this thing. She was talking about the Dragonfly mission, which is supposed to arrive now. I think it's going launching in 2028, and it arrives in 2034. It actually will go around Venus. Most of these things go around Venus to get a boost, and then they go around Earth to get a boost, and then they go out towards Jupiter. So imagine the math that has to be done to figure out how to get the trajectory right so that you end up going around Jupiter, um, or in this case, around Saturn. Sorry. So that's supposed to get to Saturn in about 2034. And the carbon rich chemistry is something that's going to be really a big input of what they're going to do. They talked a lot about the Cassini um, in the first part, and I meant to set that up and mention a little bit about the Cassini, but that's a ship that's been there for a probe that's been out there for a while, and it took some of the most fantastic pictures. You probably saw them 8, 10 years ago or so. It was supposed to be something like, once it got there, it was supposed to be maybe a 4 month process of investigating, but I think they kept it going for almost 7 years by doing boosts to its power sources and things like that too. And finally, and there's a real touching video about that. All the scientists are watching because when it finally ran out and had virtually no fuel left, they guided it into. They didn't want it to crash on some of these planets, and maybe there was some leftover of some human um, uh, biological stuff that could land someplace on one of the moons, but they guided it right into crash into Jupiter, into Saturn at the time. So, yeah, the Cassini was a pretty amazing thing and did everything they asked it to do and much, much more. This is Cassini had a little probe attached to it that actually dropped a probe onto Titan. And the first image released, this is the first image that was released, and it was taken from an altitude of about 10 miles and showing what are speculated to be drainage channels. See drainage channels here flowing to a possible shoreline. The darker areas are flat plains, and the lighter areas represent higher ground. So that was one of the first pictures that was sent back as they got a rover there. The ice giants are out further, and again, very similar in size, 4.5 times wider than the diameter of the Earth. And again, 19 astronomical units from the sun. 5 and then 10 and then 19. And Uranus is the one planet that is, because of some possible collision at some time, they think, it's got its pole facing directly towards the sun, or within, it's at 97 degrees of tilt or something. So it's facing very close to the sun, and the rings go around in that direction on it too. Again, formed in similar ways, except there's most of the helium and hydrogen was collected by Jupiter and Saturn, and so these have more methane, which makes it be, makes it a more blue color. Go back. Right? And so these are the two. This Uranus was found by a backyard telescope aficionado that in the late 1700s. And then they were plotting its path and seeing what it did. And they said, of all the mathematics and everything it did, it wasn't really orbiting the way they thought it should. And Newtonian physics was very well understood by this time, and they could plot the orbit of this planet very carefully, and it wasn't following the path that they thought it should. And some people said, well, maybe it's out of the solar system and Newtonian physics doesn't apply anymore in out of our solar system. That was one basic assumption maybe. And out there, way out there, something else occurs. And another group of people said, there's maybe something else is occurring that's causing Uranus to have this odd path to it. That's deviation from the norm. And they started doing some math and they plotted what planet would have to be where to have the impact. And I just marvel at the amount of math that they had to do to come up with that without aid of computers. I don't know, rudimentary slide rules, maybe. I don't know how they did the math to figure all this out. But we're able to determine where it would be if there was another planet that was impacting the orbit gravitationally of Uranus. And they figured out where it would be, and they put the telescopes that they had available at the time there, and they found it. It was Neptune. I keep hitting the wrong button. Did I do that? There. So they found Neptune. Again, very similar. Neptune has some of the craziest weather. I think they say that things are going at like 1,200, atmosphere winds are blowing at like 1,200 miles an hour, something like that up there. Just phenomenal, crazy atmosphere and things going on there. And again, there's a lot to be learned about them, but it takes a long time to get anything there and do it. They're more interested in sending things to Jupiter and Saturn, and then maybe as they fly by from there, maybe they'd go past here. We haven't had much past the Voyagers go out to check these things, and the Voyagers were there in the 1980s or so. So the Neptune is similar size to Uranus. It's 30 astronomical units from the sun. And if you'd be there, it's about 1/900th the sunlight received compared to Earth, what we have here. So much dimmer, right? Never bright at all or bold lighting at all, anything like that. Again, continuing the naming of them after Roman gods. Neptune was the god of the sea, and it was the blue planet, so they call it the watery planet for quite a while. So that's pretty much what I can share in an hour about these planets, the ice giants and the gas giants. And any comments or thoughts or questions? And thanks so much for coming. Yes, over here.
Wait.
Do we know what's driving the speed of the winds on Neptune?
I don't think they know. I think a lot of theories, and all of these planets, Jupiter's planets, the storms in the atmosphere, I think they're driven, I think, by internal cooling or the release of heat from their central core. They talked about that a little bit in the video, I think, and it just drives up heat that that starts swirling the planet around. And some of it is just centrifugal, and I'm not sure why and the Earth too, right? Between the Tropic of Cancer and the polar, the Arctic Circle, winds usually travel, in this direction, but below it, they call it the horse latitudes down south near the equator. Winds travel just because of the rotation of the Earth causes things to happen, and then the results, they have that impact back on them as well too. But the intense speed, I think, is heat related and the loss of heat from the central core.
Yeah, if we look at our own planet, we could see the dust storms that are generated in the Sahara Desert traveling across the Atlantic Ocean and into the Mediterranean, into the Caribbean.
Right, right, and even over into Brazil and impacting the rainstorms there too. Okay, well, thank you so much. I had a nice time studying about this. I hope you look at some YouTube videos and look in these things too. The pictures are fascinating, and the science is just enormous. Yes, here's a question too. Go ahead. Maybe how do they become ice giants? It's this accretion of a small rocky core, and then the gathering of whatever's left in the universe, in the solar system, really, around it. As they're traveling around, they're almost acting like a vacuum cleaner, like a Hoover, sweeping up everything gravitationally that's near them. Um, and the sun is sending out violent bursts of energy from it, solar winds, and sending out things there. And so they're gathering in, or they gathered in their growth, the things that were available to them in their environment. There's probably a lot more science that has to be done to determine exactly how these things combined. Did the methane that's there, which is a combination of nitrogen and helium or hydrogen, how did those things combine, and were they methane already, or did the planet do it with its gravitational energy and force to make methane out of it? There's probably way above my level of knowledge about it, but yeah, it's basically gathering the remnants of what's there from this amazing disk that started out swirling around to create our solar system in the first place. Okay. Well, thanks so much. I had a nice time doing this.